Namaskar, welcome to Prakash on Basics. I am Prakash Zog. As promised last time, we would be starting with ideas related to radioactivity. But there I also mentioned about the origin of the universe. The reason is it's the beginning of the two of them is practically the same that we must know of. To understand any complex concept, it is essential that you first understand the background of what it is. So, today, when I talk of radioactivity, I am going to talk of its background first as to how it all started. Uh, how it all started is how humans knew about it, and secondly, how it really originally started off. Probably last year sometime I had talked of what an atom is. That's long time back. So I'll just remind you that basically an atom consists of what is known as the nucleus in the center and an electron or a set of electrons that go around. The nucleus itself consists of what are known as protons, which are positive, and neutrons, which are neutral, and the number of protons decides what element it is. If there are 1, it's hydrogen, if there are 2, it's helium, if it is 3, it is lithium, and so forth, till you keep on going along the track. And the number of electrons that revolve around in different orbits is also the same as the number of protons, provided the atom is neutral. The neutrons are as good as the protons, but they don't have any charge. That's the structure of what the atom is. But then I told you in the center there is something known as the nucleus. The nucleus itself has these protons which are positive, which are obviously going to repel each other, and neutrons that are present, but they cannot repel each other. But there is a very strong force within the nucleus, which is typically referred to as the nuclear force. Details I won't go in just now. There are two of them in fact, and they are the ones which result into the attraction between not only the proton and the neutron and the neutron, but also attraction between the proton and the proton also. But these are extremely short range forces. So, it is this attractive force that keeps the whole structure together. Now, this is one aspect of what the nucleus is. Let me move to the second area. Where did it all start off with? We are going to go into details when I start of the origin of the universe, but let me remind you that there is something known as the Big Bang, where everything started off, and scientists have been able to predict what happened in nanoseconds after the Big Bang. Roughly around 225 seconds to about 1000 years is the time when helium and electrons and protons all started to be formed. That's pretty early, practically the beginning of the universe. And then this is putting the nuclei together. This is known as nucleosynthesis. Synthesis is to put together. So, hydrogen was there and helium was there, and there was a major force that we all know of known as gravity, and it is this gravity that started pulling all the hydrogen and helium together, and this started resulting into formation of the beginning or the early type of stars. And when the whole thing compressed down, it started what is typically referred to as a fusion reaction, and it resulted into the star starting to glow. But when the pressures built up, the star grew out of control and it exploded as a supernova. During that explosion, all the material inside, which was only hydrogen and helium for the first stage, resulted into banging into each other, resulting into heavier elements. and that is how heavier elements with more number of protons and neutrons were formed. These are scattered all around the universe, and then again the contraction process starts off. The result is second level of stars again collapsing and again forming new elements. And so all the higher elements other than hydrogen and helium that we know of has come from a variety of star explosions. So you and me are both star material in that sense, because every atom in our body other than hydrogen and helium has actually come from the exploding stars that we, or supernovae as they are called. So that's how elements formed, and the element formation consisted of all these neutrons and protons falling together and making a bigger and a bigger and a bigger and a bigger atom. Now this is the second stage. Now let's go into some historical facts. There were around 1890, 1880, lot of experiments were being carried out, and many people were working on different areas, and there were certain substances that used to glow. These were phosphorescent materials, and as to what causes this glow was something that was being studied for by quite a few people. One of these people was a person called Becquerel, and there were others also who were trying to study all this. Thomson was there, and Rutherford was there, and all these people contributed to certain areas that developed into the beginning of what we are talking of, which is radioactivity. People like Perry Curie, the husband of Marie Curie, and others. All these people put together a lot of ideas that made good sense of what was happening. What was happening? One of the methods of detecting radiation was to use a photographic plate. So the radiation used to fall on the photographic plate, and the photographic plate used to darken, and that used to be processed silver and so forth, and then they could find out as to what radiation was falling or whether radiation was falling or not. Now this person Becquerel, who was trying to study the phosphorescence and phosphorescence type of properties, had stored certain substances in a cupboard in which there were photographic plates, and he found afterwards that all these photographic plates were already exposed, they were already darkened. So he sensibly realized that it must be these chemicals that were put on top or close to it that must have caused this. So he started testing out what was happening, and many of them were uranium salts, and he realized that uranium was giving out some form of radiation which was as good as light, which could darken photographic plates. Then he started trying to work out on different other materials. Uranium among them was the most common, but when he tried out other salts of uranium, he found that the amount of darkening was practically the same. And then he realized that there was something special that was happening, and they realized that some form of radiation was coming out of it. Now we come to a second experiment. There was this very important scientist called Rutherford. He did a lot of things. We talked of it when we talked of the atom, but what he did was, when he found out all this issue with Becquerel, they realized that if the material was coated or preserved in a lead container, this photographic darkening of photographic plate was not happening. So he realized that lead was stopping this radiation. So in order to study what this radiation was, Rutherford did something very simple. He took a container which had a very small opening, and in it he put the radioactive material, which obviously was a uranium salt of some sort, and on top he put a photographic plate. Naturally, the radiation could not go from any side, but it could go only straight up through the small hole that was present on the photographic plate, and when the photographic plate was processed, there could be a dark spot indicating the beam of radiation that was falling. Now, what he did was, he applied on either sides of this beam an electric field. What's an electric field? A positive plate and a negative plate, and they were given the corresponding voltages. So, there was an electric set of lines that were present in between, and we know, when I talked of electricity, that if there is something that is negatively charged, it will get attracted towards the positive, and if it is positively charged, it will get attracted to the negative. So, when this set of plates was put, instead of seeing one dot on top, they started seeing 3 dots. One shifted towards the positive, one shifted towards the negative, and a central one that remained as it is. That's not all. They found that the one that bent towards the positive had bent more, while the one that had bent towards the negative had bent very little. Now, what we have to realize is how this was interpreted. Obviously, the one that bent towards the positive must be originally negative, but since it bent more, there are two possibilities. One, that radiation must be consisting of something that was very light, that is why it was bending more, or it must have had more amount of charge. Secondly, the one that was bending towards the negative must have been positive, but it was bending less and very small, which meant that it must be a very heavy particle. And the one that was not deviating at all was obviously something that did not have any sort of a positive or a negative charge. So, Rutherford clearly indicated that there must be a possibility of the radiation consisting of 3 things. So, he called them like the Greek alphabets: alpha, beta and gamma. Alpha was the one that bent towards the positive, towards the negative, and which must be positive in nature. Beta, that bent towards the positive, which must be originally negative, and the third one, gamma, that did not bend at all. And they found that every set of uranium atoms resulted into same type of alpha, beta and gamma radiation. They tested out a lot of elements, and they found that all elements higher than lead in their structure or weight were giving out radiations of this sort. And so, all such materials were called radioactive materials. So, what we have is a situation where substances were now identified as something known as radioactive materials. Now, let us come to the third step. To understand the third step, there are 2 things. One, we must know how these are represented. I told you the type of forces that exist between the proton, 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 neutron, neutron, neutron and so forth, which are the nuclear forces, and the electrons are going around. They found that if they change the chemical composition, nothing changed as far as alpha, beta and gamma were concerned, which meant that they had nothing to do with those electrons that were going around in the atom. it was basically a property of the nucleus of these substances. So, one of the major and the most important conclusion was that radioactivity is associated with the nucleus. Good, we have one big step. Now, there is one more aspect of atoms that we must realize now. In the nucleus, protons and protons are going to repel because they are both positively charged. But what is holding them together is the nuclear force that is around. And to add on to this amount of force, you have an extra number of neutrons that are present. So, the instant you talk of something like helium, there are 2 protons, but in addition there are 2 more neutrons. And this process keeps on going on. Up to roughly around 20 protons, the number of neutrons remains 20. But later on, this strength of the neutrons equal number to hold the whole system stable does not work. So, what happens? They try to put in more number of neutrons. Nature tries to put in more number of neutrons to compensate and provide the extra amount of binding to the nucleus. And so, the number of neutrons starts building up faster and faster than the number of protons that are present. Remember, I talked of something known as lead some time back. So, by the time you reach this lead, there are 82 protons, but the total number of protons and neutrons is 204. What does it mean? That means there are 82 protons balanced by a very much larger 204 minus 82 number of neutrons that are required to hold the system together. And that is the last stable element. After that, there is no stability. The whole thing starts breaking down. How do you understand this? Let me give you an example to clarify this. We all know how laddus are made. What you have is syrup, which is the binder, and you have small particles that make up the laddu. And so, how is a laddu made? So, you take those particles, which are either neutrons or protons, and add the syrup, which is the binding force, and make a laddu out of it. But as the laddu starts becoming bigger and bigger and bigger and bigger, there is a limit. You must have seen in South India and other areas, they make very big laddus as a gift to God or something of this sort. It's pretty difficult to make them, because beyond a certain limit, the instant you try to make a bigger laddu, the whole thing collapses off because of gravity and other factors. The binding strength is not enough to keep the whole thing together. What would possibly happen? Just think. I want to make it a little bigger, so I take a lump of the syrup and the material and add it on. Two things can happen. The whole thing will break down into 2 parts, or as soon as I add one part, a second part from this side will fall off because it cannot really hold on together. This is exactly what happens as far as the nucleus is concerned. After a certain limit, the whole system becomes unstable. So, when nature tries to build up by putting more number of protons, the syrup, that is the nuclear force, is not strong enough to hold the whole system together. So, what happens? A small chunk of it falls off. Every time this happens, the whole system tends to become more stable, by dropping off a chunk. In case of a laddu, it is the syrup and the particles that fall off, the bundis that fall off. But in nature, in the nucleus, there are two things that can happen. Either it loses energy, or it loses energy plus a little bit of mass and tries to become stable. So, when elements beyond lead in the number of protons try to increase beyond this limit, they are inherently unstable and they tend to give out or lose either radiation in the form of just energy or particles plus energy, and that's nothing but alpha, beta and gamma. Beyond A282, that is lead, this happens naturally. So, such radioactivity is known as natural radioactivity or spontaneous radioactivity. But there is another possibility. Think of a laddu that is not really that big that it will collapse. It's relatively small, something that is manageable. Now what I do is I force a slightly bigger object within the laddu, maybe something like a ball bearing. Using a small toy gun, I fire a ball bearing that shoots into the laddu. It can't fit in inside, so it makes the whole system unstable, and a chunk of it falls off, or the whole laddu splits into two parts. So this is something that has happened because of an external particle that has been pushed inside that collapses the laddu. Can I do this to the nucleus? Of course you can. You take a very high energy particle and push it into the nucleus, and the result is the same. If that happens, the nucleus becomes unstable. What will it do? It will either give out a small chunk or it will break down. This is artificial radioactivity that has been induced because of an external factor. And so it starts giving out either energy, which is that gamma radiation, or it gives out a heavy chunk of mass, which is that alpha radiation, which is nothing but the nucleus of helium atom. And one more thing happens. Inside, because of these collision processes, some of the neutrons convert into protons and an electron, and that electron with an excess energy is shot out, and the excess number of protons are put together with two more neutrons and are given out as an alpha particle. So the whole system tries to become stable on its own. This is exactly what happens in radioactivity. So radioactivity is basically an unstable form of an element which is either naturally unstable or made unstable. If it is beyond lead, it is naturally unstable. It tries to become stable by giving out three things: alpha particles, beta particles and gamma radiation. Gamma radiation is nothing but electromagnetic radiation, like radiation that we talked of. And the amount of bending that I talked of in alpha and beta can also be achieved by using a magnetic field instead of an electric field. So these have also been studied. So radiation that we talk of is a property of the nucleus, and it is in the form of alpha, beta and gamma radiation that comes out. Or we can make an ordinary good material unstable by various reasons. How? I am going to come to later on. And make it unstable and cause it to become radioactive. carbon 14 or cobalt 60. Originally it is supposed to be a different number, it has been made into a different number, and that is the artificial radioactivity that has been induced in it. So this is what radioactivity is. It is associated with the nucleus. So whether you heat it or whether you cool it or you change it from an oxide into a chloride or any other chemical composition, all those are dependent upon the external electrons. This is a nuclear part, so it is unaffected by anything else, and that's exactly what happens. So radioactivity is a nuclear property. Radioactivity gives out energy and mass, which is known as loss, and so the element changes. Once the number of protons change, the element becomes different. So the original one is known as the parent element, and the new one is known as a daughter element. It is possible that the daughter itself may be radioactive and it can produce granddaughters and so forth. The process of losing energy and mass is said to be the decay of the element. So this is many a times known as radioactive decay. So this is the beginning of what radioactivity is. It's a very interesting area because there are a lot of applications, right from creating nuclear reactors to atomic bombs and so many other things, and chemical medical treatments and so forth. But how does all that happen? We need to understand that. If you have liked whatever I have said, uh, please try to read up a little bit about this and try and tell your friends about this. Let them also understand what radioactivity is. This is just the beginning. We need to go deeper into what radioactivity is. For this, we'll meet again. Till then, Namaskar.